So this should be the last lesson for Unit 8. We're going to look at what are called natural logarithms, or the ln key on your calculator. Ln is natural logarithm. So we want to, again, remember how to change forms from exponential form to log form and back from log to exponential. So remember down, cross, cross. We talked about the common logarithm. So that's a logarithm with base 10. So remember, if you don't see a base, it's automatically 10. And that's called the common logarithm. And then we have this new logarithm. It's called the natural logarithm. And this is a log that has a subscript or a base of e. So remember, e we talked about is 2.718 approximately. So that's what the ln key is doing. It's doing log base e, which is like 2.718. All right, so we want to go ahead and kind of review everything that we did from 8.1 to 8.3, other than the graphing. We could do the graphing also with this, but pretty much everything that we did with 8.1 to 8.3 kind of comes in this one unit 8.4 with natural logarithms. Okay, so first we're going to go ahead and practice, again, rewriting each exponential equation in log form. All right, so remember down, cross, cross again. So log, our base is e, x equals 14. Now log base e you can rewrite as ln, and then x equals 14. All right, so ln x equals 14 is the same as log base e, x equals 14. Number 2, e to the third equals 20.08. Again, down, and then 20.08 equals the exponent 3. Log base e is ln. 20.08 equals 3. Number 3, again, e is our base. So log base e, 4 equals x plus 1. Okay, again, if you need to rewrite it, you could rewrite it at the beginning as e to the x plus 1 equals 4. And so then again, you can see as log base e4 equals x plus 1. Again, log base e is ln 4 equals x plus 1. All right, so now let's go ahead and do the reverse. Each log form, we're going to change to exponential form. Again, ln is log base e, x equals 2. So now we can see our base, the subscript is e, and then the 2 goes up as an exponent, equals x. So e squared equals x. Number 5, again, ln is log base e, 4x equals 1.6. Changing the form would be e to the 1.6 equals 4x. You can put the parentheses around the 4x if you want. Number 6, again, if you want to rewrite this as ln x equals 8, that's fine. Ln is log base e, x equals 8. So then exponential form, e to the 8th power equals x. All right, so we're going to simplify each of these using condensing properties. All right, so just like with log properties, if we're adding 2 natural logs, then we can condense into multiplication. If we're subtracting, we can condense into a fraction. All right, so this is going to be ln 3 times 6, which is ln 18. Again, if you want to put the parentheses around it, you can. You don't have to. You can just write it as ln 18. Number 8, ln 8 minus ln 2. Okay, subtraction to fraction. So ln 8 over 2. We could simplify this fraction down. 8 over 2 is 4. All right, number 9, working left to right, we can condense these two first. So that's ln 5 times 4 minus ln 2. Then that's ln 20 minus ln 2. Subtraction to fraction, ln 20 over 2. And then we can simplify the fraction, ln 10. All right, number 10, let's see, we have a coefficient, that 1/3, that's going to go up as an exponent first. So that's ln 8 to the 1/3 minus ln 3 plus ln 9. All right, again, we're going to work left to right and take the first two logs that we come in contact with. So we have subtraction, so we'll condense that into a fraction. All right, now 8 to the 1/3 is also the cube root of 8 over 3 plus ln 9. All right, and then addition condenses to multiplication. Now, cube root of 8 can simplify. The cube root of 8 is 2. So we have 2/3 times 9. Now we can multiply 2/3 times 9. Put the 9 over 1. You can multiply straight across, 2 times 9, 3 times 1, and then simplify the fraction if you want. Or you can just cross cancel first. So it's ln 6. All right, so now we're going to go ahead and solve exponential equations. So it's similar to what we did, I think, in 8.3. So we're going to isolate the e to the x term. So if there's something being multiplied in front of the e term, we're going to divide that over. If there's something that's added or subtracted to the e to the x term, we're going to add or subtract that over. So isolate that first, then you're going to change to log form, and then you can solve for x. Okay, so in number 11, the e to the x term is already isolated, so that x plus 1 is an exponent, so you can't break that up. So now we're going to go ahead and change it to log form. All right, so down cross cross, so log base e 6 equals the exponent x plus 1. Now log base e again is ln 6 equals x plus 1. And then we're going to go ahead and subtract the 1 over. All right, so we have ln 6. Now this is where it's kind of important to put those parentheses around it, the 6 minus 1. And that's so you don't try to subtract 1 from just the 6 and make it a 5. You're actually subtracting 1 from ln 6. So if you don't put the parentheses around the 6, you're going to probably want to subtract 6 minus 1 and make it ln 5, and that's a different answer. All right, so ln 6 minus 1 is the exact answer. Now, some of these problems, again, we're going to give the exact and decimal just so we can practice using the calculator also. So ln 6 minus 1 is the exact answer. Now we're going to go ahead and give the decimal. So we'll put in ln 6, okay, then minus 1. Make sure that minus 1's on the outside of the parentheses. If your calculator opens a parentheses, make sure you close it around the 6 and then minus 1. All right, so the answer should be 0.792. We're going to go to 3 decimal places on this, 792. All right, so that's the approximation for ln 6 minus 1. All right, number 12. Again, we're going to isolate that e to the x minus 3 part. That's the term that we're isolating. So here we're going to subtract 8 first. So 2 times e to the x minus 3 equals 12 minus 8 is 4. Then we can divide both sides by 2. So e to the x minus 3 equals 2. All right, so now we have the e to the x term isolated, so now we can change the form. So log base e 2 equals x minus 3. That's ln 2 equals x minus 3. Then we can add the 3 over. Again, I would suggest putting that 2 in parentheses, and you'll see most of your calculators are going to put it in there anyways, so that's why it's a good habit to put it in. Okay, so ln 2 minus 3 is the exact answer, and then we're going to go ahead and put that in the calculator to get a decimal. All right, so find your ln key, 2. We're going to close the parentheses, and then we can hit plus 3. Again, we'll go to 3 decimal places, so 3.693. All right, so solving ln equations. Again, similar to what we already did in, I believe, 8.2. Okay, again, this is just kind of a review. When there's one log in the problem, you're going to isolate the log term, change to exponential, and then solve for x. You do have to check again, make sure you don't get false solutions or extraneous solutions. When there's one log term on each side of the equal sign, cancel the logs out and then solve it. Again, get a check. And then if there's two logs on the same side, condense into one log first, and then you'll either change to exponential form or you'll cancel the logs out on each side of the equal sign. And then again, make sure you check. Okay. So 13, 8 times ln 5x equals 2. All right, so we have one log in the problem. And so we're going to isolate the log first. So that means that we can divide both sides by 8. Right. So that cancels that out. We get ln 5x equals 1/4. All right, so we've isolated the log. And now we're going to go ahead and change the form because there's only one log in this problem. And so we're going to change it to exponential. So ln, remember, is log base e. So this is going to be e to the 1/4 power equals 5x. And then we'll divide by 5. All right, so here's our exact answer. All right, so it says exact, that's e to the 1/4 power divided by 5. Now let's go ahead and give a decimal answer. All right, and so find your E button. Again, it's just above the ln. So e to the 1/4. Okay, we can hit equal sign. Okay, it's going to be like 1.2840. Then just hit divided by 5. All right, and then again, we're going to round to 3 decimal places. So 0.257. That's the decimal. All right, number 14. We have 2 logs on the same side, so we're going to condense. And so addition condenses to multiplication. That's x times 2 equals 7. Or 2x, ln 2x equals 7. We have one log in the problem, so we're going to go to exponential. Again, ln has a base e, so it's e to the 7th equals 2x. Again, we're trying to get x by itself, so we divide by 2 here, and so e to the 7th over 2. E to the 7th over 2, that's the exact answer. And then again, we can get the decimal answer. All right, e to the 7th divided by 2. All right, again, go 3 decimal places, so 548.317. All right, 15, we have one ln or log on each side, so we can cancel the logs out. Set the left side equal to the right side. All right, solving for x, subtract x over. -4 equals x plus 3, subtract 3. So x equals -7. All right. So the other 2 problems before, again, you have to check your answers. So let's check it on this one. We can go back and check the other ones. So if we take -7, we plug it in for x right there. -7 minus 4 is -11. Since it stays a negative value, you can't have that. And so this is no solution. And which obviously there's no decimal answer for no solution. Let's go back and check these ones real quick. Again, 0.27, that's positive. If you put it in for x and multiply it by a +5, it stays positive, so that's good. Question 14, 548.317. If you take that and plug it in, since it's positive already, it stays positive, so that's good. All right, 16, again, there's 2 logs on the same side, so we're going to condense. Addition to multiplication, so 4x times x equals 12. Again, that's just 4x squared equals 12. Change from log form to exponential, so it's e to the 12th equals 4x squared. Okay, we'll divide by 4, divide by 4. And then since we have that x squared, we're going to square root both sides. Square root, and don't forget plus or minus. Now we can simplify this. Okay, so again, this is plus or minus square root of e to the 12th over square root of 4. Just broke up the radical. So with the square root of e to the 12th, remember the index is 2 for the radical, and you can divide 2 into 12 6 times. So that's e to the 6th on top. On the bottom, the square root of 4, that's just 2. All right, so we have plus or minus e to the 6th over 2. Now, that means there's two possible answers, the positive one and the negative one. And so if you were to take and plug it in for x, okay, plug it in here, plug it in here, you can see that the negative one is going to make it negative. So you can only keep the positive one. All right, so the positive exact answer is e to the 6th over 2. All right, and then again, we get the decimal. All right, so e to the 6th divided by 2, 201.714. All right, again, if you were to check the negative value on that, it would just be negative 201.714. If you plugged it in for x, it's going to make it negative, and that's why you can't use the negative one. So only the positive one works. All right, and last one, word problem. Suppose $10 is invested at 8% interest compounded continuously. When will the investment be worth $100? Round to 3 decimal places. Okay, so we did a problem like this on, I think it was a bonus question on the Unit 7 test, where you just guess and check values. Well, this is using algebra to actually solve it. So let's plug the numbers in. They give us the formula A equals P times E to the RT. So we're investing $10, that's P, your principal, and we want to know how much time is it going to take for it to be worth $100. That's the ending amount, that's A. So plugging these numbers into the formula is going to be 100 equals 10 times E to the R, which is the interest rate as a decimal. 8% would be 0.08, and then T is what we don't know. All right, so we're solving for t, so the first step here is to divide both sides by 10. 100 divided by 10 is 10 equals e to the 0.08t. All right, now since our variable is up in the exponent position, we have to use logs to solve this. And so we're going to change it from exponential into log. If you like to have that e to the 0.08t on the left side, just switch it around. It's not a big deal. All right, and so changing this to log form, this is log base e, and then cross cross, down cross cross equals 0.08t. All right, now log e is ln, ln 10 equals 0.08t, and then we're going to divide both sides by 0.08, 0.08. All right, so ln 10 over 0.08. Okay, so that's obviously the exact answer. We're going to go ahead and put this in the calculator and let the calculator calculate it. Again, we'll go 3 decimal places. So ln 10, and then divide that answer by 0.08. All right, so 28.782, and that's going to take years. Okay, so almost 29 years to go from $10 to $100 at that interest rate. All right, and that's it.